Okay, here's a problem where we're going to determine the mass of 10 water molecules. Whenever you see a problem that involves a number of molecules, automatically think of a conversion factor we know. Avogadro's number is 6.02 times 10 to the 23rd molecules per mole. You're probably going to need that. And let's just go ahead and start from there. I have two numbers given. Maybe you only see one right off. I have this one, but there's also a number given in my statement, and it's 10. 10 molecules. Of those two numbers, which one would I start with? I want to start with the number that has just one unit, just one number with one unit, and that is going to be the 10 water molecules. Now notice that I wrote out 10 instead of writing the number. And there's a reason for that. When it's written out like this, it implies that that number is exact. That means it has infinite sig figs. It's exactly, I'm talking about exactly 10 molecules. It will not affect how many sig figs I have in my answer, which Avogadro's number will. This number has been rounded off. It only has 3 sig figs. So I'm starting with my 10 molecules. I know that I'm trying to get rid of molecules. I'm trying to get to mass, which would be grams. We'll put molecules down here so that it will cancel. Be careful not to abbreviate molecules because a molecule and a mole look very similar when you abbreviate molecules. So either write out the word molecules or abbreviate it just cules or something like that. Okay, so molecules down here. I can use Avogadro's number to go to moles, so I'll do that next. I'll go to moles. So the 6.02 goes with the molecules, so down here. One mole. Okay, I'm still not there. Right now the molecules would cancel. My answer would be in moles. It asked for mass, that's grams. So I need to get rid of moles and somehow go to grams. And maybe you know there's a way we can get a conversion factor that goes between grams and moles, and it is the molar mass. The molar mass depends on the substance. H2O, I look on the periodic table, and 2 times 1 for the hydrogen plus 16 for the oxygen. So that gives me 18.0 grams per mole for water. When I use this conversion factor, I need to make sure the 18 stays with the G, so it'll go on top. And there's a 1 implied down here. Now my moles would cancel. Punch this out real quick. And my calculator says 2.9900 times 10 to the minus 22. On sig figs though, I'm going to round. Remember this 10 is exact because it was written out. And these numbers both have 3 sig figs, so I need just 3 sig figs. I get the number 2.99 times 10 to the negative 22. That's grams. I should ask myself, does that make sense? Does it make sense that 10 molecules would have a mass like this? That's a very, very small number to the negative 22. So yes, that does make sense.